Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Ana Miranda. My metric ID is 0221505. I will explain about three-dimensional speech. Briefly, we had to know the meaning of point, line, and plane. A point is an abstract canvas that is intangibly or shapeless. Has no size or magnitude, no length, no width, and no substance. To describe a point, a symbol or model is needed. As follows. The symbol or model of a point is usually given a name. The name for a point is usually symbolized by a capital letter placed near the point. For example, a line is an idea or concept that is straight and extends in both directions, is unlimited, has no width, no height, and cannot be touched. To draw a line, you can do it by making stationary strokes as follows. Accompanying a line can be done using two methods. First, with a small letter at one end of the line. The second uses two capital letters placed at 2 points on the line. Below is how to accompany the line as follows. A plane is defined as a flat surface that extends in all directions, is long, width, has no thickness, and cannot be touched. For example, the surface of a glass, the surface of a floor, the surface of a sheet of paper, or the surface of a classroom wall. You can name a field using lowercase letters, uppercase letters, or Greek letters such as alpha, beta, and gamma. Speech is defined as a geometry element that has length, width, and height that continues to expand indefinitely. 3. Speech is carried a three-dimensional shape because it has three elements, namely length, width, and height. Examples are cubes, blocks, frames, and others.
Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Hastina Dewi. My metric ID H02210005. Here I will continue the material from my friend, namely Euclid's axioms. An axiom is a statement that is assumed to be true in a system and that truth is kept without proof. Euclid introduced three important axioms in geometry. Axiom 1. Through any 2 points which do not coincide, a straight line can only be drawn. Axiom 2. If a line and a plane have 2 common points, then the line lies entirely in the plane. Axiom 3. Through 3 arbitrary points, not on one line, a plane can only be created. Violet. Proposition 1. A plane is defined by 3 arbitrary points. Proposition 2. A plane is defined by a line and a point. The point is outside the line. Proposition 3. A plane is defined by 2 intersecting lines. Proposition 4. A plane is defined by 2 parallel lines. Point position. Position of points on lines. 1. The point lies on the line. The point is located on the line. It can also be interpreted that the line passes through the point. 2. The point is outside the line. The point is located outside the line. It can also be interpreted that the line does not pass through that point. Position of a point regarding a plane. 1. The point lies in the plane. The point lies in the plane. It can also be interpreted that the plane passes through the point. 2. The point is outside the plane. The point lies outside the plane. It can also be interpreted that the file does not pass through that point at all.
Let me introduce myself. My name is Nurmaya. My metric ID 80221003. I will explain about line position. The position of a line relative to another line. 1. Two line intersect. There is one federation point. Line AB intersect with type P and only at point B, or line AB else intersects with line BC, namely at point B2. It can be concluded that AB intersects BV at point BC at point B and are perpendicular to each other. 2. Two lines coincide. There is more than one point of communion. For example, like this, line AB will coincide with line AB2. Well, usually we see it coincide. This is to yes or by. It will also coincide with line B if he or line BC it will also coincide with line BC. Will this is what we call cross coincide. 3. Two lines that intersect. Does not intersect, does not cross, does not lie in one plane. B. Its two lines are said to intersect if the two lines are not located on the same flat plane and will not intersect if extended or drawn. The two against a flat plane cannot be created. For example, brush the against AB will intersect with the CV line because this AB line is located in the ABCD plane while this against CV. 4. Two parallel lines. There is no point of commonality in one plane. In one flat plane but do not have a common length of intersection. Then it can be concluded as follows. For example, dash line AB will be parallel to line CD because it is located on a flat plane, namely the AB plane. So the extension of lines AB and CU will not intersect or have no intersection point, so we can conclude that AB dash will also be parallel to the line G8. The plane of the N is ABG8. Then let's can conclude that against AB will be parallel to against. Axiom 4. Draw a point that is outside a line. Only a line can be drawn parallel to that line. G crossed with CG, DH, AH, and FG. G intersects with AD, AE, BC, and BF. G parallel to DC, AF, and HG. The theorem about two parallel lines. Theorem 5. K parallel I parallel M. So K parallel M. Theorem 6. K parallel A, K and A cut G. So K, I and G located in one plane. Theorem 7. K parallel I penetrate the field A, so K penetrate the field A. The position of a line relative to a plane. 1. The line lies in the plane. 2 or more common points. 2. Parallel lines to the planes. There are no points of association. 3. Line cutting plane. There is one common point, breaking rock point. Lines parallel to a plane ABCD is AF, GH, AH, and FG. Lines that lie in a plane ABCD is AB, AD, CD, and BC. Lines that intersect plane ABCD is IA, FB, CD, and DH. Theorem about lines parallel to planes. Theorem 8. G parallel H lies in the first A, so G parallel field A. Theorem 9. A through G parallel field beta, so A beta parallel G. Theorem 11. A intersects with beta, A parallel G, beta parallel G, so A beta parallel G. Theorem 19. G parallel H parallel field A, so G parallel field A.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Introduction, my name is Honda Talib. My metric ID H02210006. I will explain about field position. The fields namely two planes coincide. Two planes are said to coincide if every point lies in both planes as seen in the picture to the side. And two parallel fields. Two planes are said to be parallel if the two planes do not have a common point as in the picture to the side. And 3. Two planes intersect. Two planes are said intersect in the two planes have the same line as in the picture to the side. Next plane and theorem. Theorem 12. A parallel G, B parallel H, and A and B intersect in the plane AG, and H intersects in the plane beta, so field A parallel field beta. And theorem 13. Field A parallel field beta, field mu catching field A and beta, so A mu parallel B mu. And theorem 14. G penetrates A field A parallel field beta, so G penetrates the field beta. And theorem 15. G parallel fields A, field A parallel field beta, so G parallel field beta. And theorem 16, G locates in the field A parallel field beta, so G parallel field beta. Theorem 17, field A parallel field beta, field mu cutting field NA, so field mu cutting field beta. Theorem 18, field A parallel bidang field A parallel field beta parallel field mu, so field A parallel field mu. And theorem 19, field A parallel field U, field beta parallel field V. Field A and field beta intersect at A beta. Field U and field V intersect at U V. So A beta parallel U V. Example. We can see in the picture known as a chart ABCD EFGH. Determine the fields, namely points that are on a linked if, points that are outside the planes BCHE, lines parallel to CF, lines that intersect with BE, lines that intersect with PG. A plane parallel to A planes BDG. Okay, answer from points that are on a line if, that is point D and if. And answer from points that are outside the plane BCHA, that is point ADFG. Answer from lines parallel of CV, that is DA. Answer from lines that intersect with BE, that is AAA, AF, AD, AH. And answer from lines that intersect with PG, that is AB, DC, AE, DH. And answer from a plane parallel to a plane BDG, that is AFH. That's enough from me. It will be continued by the next government. Thank you. That's enough from me. The next speaker will continue. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Nafsia Himalia Putri. My metric ID 80222126, and I will explain about distance between 2 points, 2 lines, and a plane. Okay, first, distance from point to point, to line, and point to plane. First part, point to point distance. The distance between 2 points is the length of the line segment connecting the points. If D is the point distance A, x1, y1 to the point B, x2, y2, so distance D can be determined with using the formula D equals AB equals square root x2 minus x1 square plus y2 minus y1 square. This is the formula from point to point distance. Next, part 2, distance from point to line. The distance between a point and a line is the length of the line segment drawn from the point and perpendicular to the line. If D is the point distance P x1, y1 to the line G equals A x plus B y plus C equals 0, so distance D can be determined using the formula D equals A x1 plus B y1 plus C fraction square root A square plus B square. Part 3. Point to plane distance. The distance between a point and a plane is the length of the perpendicular line segment connecting the point to the plane. Example: known as a cube A, B, C, D, E, F, G, H with rib length square root 6 cm. Calculate the distance to the points A to the line CFI. Answer: R equals square root 6 cm. AC equals CF equals R square root 2 equals square root 6 times square root 2 equals square root 12 equals 2 square root 3. Next, CI equals FI equals half. So, CF equals half times 2 square root 3 equals square root 3. Square root AC square minus CI square equals square root 2 square root 3 square minus square root 3 square equals 12 minus 3 equals square root 9 equals 3. So, point distance A to the line CFI is 3 cm. Next, point 2. Distance from line to line, line to plane, and plane to plane. A line is said to be perpendicular to a plane if and only if the line is perpendicular to two straight lines that pass through the point of intersection of the line with the plane. Example: known as a cube PQRS TUVW with rib length 6 cm. Determine distance T to R, distance P to TR, distance T to the field QSR, distance W U to PR, distance W U to PQS, and distance T U W to QSR. Answer: first, distance T to R. To find distance T to R, we can use the Pythagorean theorem. So, TR equals square root PR square plus PT square equals square root 6 square plus 6 square equals square root 36 plus 36 equals square root 72 equals square root 36 times square root 2 equals 6 square root 2. So, distance T to R equals 6 square root 2 cm. Next, distance P to TR equals PT times PR divided TR equals 6 times 6 square root 2 divided 6 square root 3 equals 2 square root 6 cm. Next, distance T to the field QSR. Distance T to the field QSR equals TO. We can find TO from triangle PTO. So, TO equals square root PO square plus PT square. PO length is half the side diagonal. The formula for the side diagonal is S square root 2. So the diagonal of the side is 6 square root 2. Because the length PO is half the diagonal of the side, then 6 square root 2 divided 2 equals 3 square root 2. So TO equals square root 3 square root 2 square plus 6 square equals square root 18 plus 36 equals square root 54 equals square root 9 times square root 6 equals 3 square root 6. Next, distance W U to PR equals length of edge of the cube. Because the edge length of the cube is 6 cm, the distance from line W U to PR is 6 cm. Next, distance W U to PQS equals 5 cm, and distance TU W to QSR equals 6 cm. Okay, thank you for your attention. Hopefully what we present can be of benefit to all of us. Wassalamualaikum warahmatullahi wabarakatuh.